Let's now start implementing our keyboard and mouse control. For that, we're going to go back to the library, and under MicroBots, I am going to double click to create a new asset group, and I'm going to call this asset group scripts. In scripts, I'm going to go under asset and create a new script that I'm going to call bot controller. And I am going to create by default the event on update, on tush moved, and on keyboard. Create, and I'm going to go under properties application and turn off the previous controller that was there, part of the sandbox. Add a new thread, open it up, drag and drop our bot controller, and jump to the coding layout. Open up our newly created script, and we are going to start by adding a few variables at the top of the script that are basically going to declare our WASD as a bit 1, 2, 4, and 8. We're going to have an accumulation for our rotation X, another one for our rotation Z, WASD, which will be a bit mask taking in the cap that we have declared here. So we are able to push up and right or down and left, in example. The speed will be our default running speed, which is the average human walking speed multiplied by 4. And the view would be 90 degrees per second. Once we have that in place, we're going to jump to the on keyboard to start implementing the test of the key W, A, S, and D. So the code is basically very simple. We are checking if the key code that we receive in the event is either uppercase or lowercase, in this case W. If it's key press and we have basically the bit W in the bit mask WASD, if we do not have it, we're going to add it. If we already have it and the key press is false, we are going to minus it. So like that, we are going to be able to accumulate and change the bit depending on which key is currently pressed. So at all time, we have a representation of the combination on the keyboard that will be placed under WASD. Next, we are going to jump over the on tush moved event, and we are simply going to take the mouse delta multiply by our view speed. So the left and right, the X, will be our rotation Z, and up and down will be our rotation X. So we're going to accumulate by saying our rotation Z equal to rotation Z minus the delta, in this case X, multiplied by our view speed here. And we're going to repeat the same process for the X, except that this time we are going to clamp the rotation to be in the range of minus 60 to 60, which will basically block the player to be able to look fully straight up or fully straight down. We're going to be inside a mid-range that look fairly realistic. Next, we're going to start building our onUpdate function that will happen on every frame. And the first thing that we're going to do, we are going to start by declaring a few variable that is going to help us to reconstruct our direction vector. So for W, A, S, and D, we are checking if the bit is present inside our bit mask. And if it is, we are going to assign the good direction. In this case, W will bring the axis Y to -1. If A is present in WASD, the X will be 1, and so on, Y at 1 if it's S, and D -1 for the X. Once we got our direction vector created, we're going to be able to pass that to our user controller. Our user controller will basically grab the current scene, the first scene that it's actually active here in properties application. Give me the first scene and store it inside the scene variable. Then we're going to grab our camera object. We are going to grab our controller, and the first attachment of our controller is our bot object. Once we got the bot object, we are going to be able to extract the gun that it's part of our camera. The camera basically have 4 objects attached to it. There's our probe 0, 1, and 2 for our cascaded shadow map. and we lately added the gun here. So I create a helper function that receive an object and check all the attachment of this specific object for a specific substring. So I am going to add that in. I am going to go fetch my get attachment function, which is pretty straightforward. For the number of attachment of this object receiving parameter, if the name, the substring is found, return the attachment. If it is not found, simply return nil. So that is going to help us to get our gun out of our camera. The gun object name is blaster. So for looping through all the attachment of that camera, the first object that show up, the keyword blaster, will be returned, which is basically our gun. Next, we are going to go fetch the elliptic constraint that we have created earlier that is orbiting around the head of our skeletal mesh. And for the amount of rotation that we have on the X and the Z, we're simply going to translate that and assign them to the X and Z angle here. So if I, in example, comment this section here just to test that specific part of the code I'm going to build. And as you can see, as I move my mouse left and right, we got our angle X and Z that is actually changing. Now, since this axis, this direction vector is basically world vector, we need to translate this direction to bot space. So wherever the robot is looking forward will be our new forward axis, and then WASD, the direction, will derive from there. So in order to do that, what we're going to do is we are going to take the robot basis matrix and we are going to assign to it our rotation Z, just the same way we're doing it by assigning it to our elliptic constraint. So we are rotating the camera around. We are also going to synchronize the robot rotation Z. And if we are having a length of axis that is greater than 0, we are going to multiply that axis by the robot basis matrix. And we are going to ensure that this direction vector is actually normalized. Once we have this, we are going to be able to send that data over to a function that I call bot controller. This function will be basically 2-in-1. We are going to use it to drive the player input and also to drive the AI input. So we are going to build the bot controller function that I'm going to put right on top of my onUpdate, and it will take in parameter the bot controller object and the direction for the moment, the direction where the player or the non-player character want to go. So we are going to extract first the bot. We could have just send it in parameter, just keep things simple and clear. So we are going to extract the bot object first, and we are going to fetch it by getting the first attachment at 0 of the bot controller. Then we're going to grab the two variables that actually drive our action controller. As you remember, if we go back and select bot object, have a action controller that is connected to it. And when we actually connect that controller, we sync the variable of that action controller, which then give us the following member variable. So what we're going to do, we're going to extract the axis X and the axis Y, and we're going to assign to that variable the axis, the direction that we're receiving in parameter. Like that, our robots, regardless if it is player or non-player character, will then be able to blend the current action, the run forward, backward, left, and right based on the direction vector of the robot. Next, we are going to extract the rigid body that we have set earlier on our bot controller, and we are going to check if we got a length of axis different than 0, meaning that the player or non-player is actually moving in a specific direction. We are now going to, this is redundant, using the rigid body of that controller, we are going to then assign the linear velocity our axis receiving parameter, our direction where the robot want to go, multiply by our global variable speed here. And similar as the way if you have followed the previous micro games, in a similar fashion that we're doing it in Microland, what we want is, as long as the player or non-player is moving, we want to have a smooth movement on the ground. And as soon as we stop moving, we want to stop right away. So what we're going to do, we're going to set the friction of the physics object to be 0 as long as the character, the bot, is moving. And as soon as we release the key, we're going to set a relatively high friction of 10, which should bring us to a stop right away. So now I got everything in place, and I am now going to compile. And we can see that now our bot is at 90 degrees down, but as I move my gun, we can see that it's still rotating properly on the right, left, and up and down as well here. So what I'm going to do with the bot selected, I am simply going to add a constraint. I could have done it here by changing directly. It's just adding the 90 degree here on the X. I'm simply going to add a offset rotation constraint and simply put 90 degree, which should put me straight up. So as you can see, wherever I move, my robot is moving. As I push forward, let me increase the application time because we are dealing with physics. So basically the linear velocity X and Y can only be updated if we got our application time that is running. So as I move forward, we can see that the animation seems to change, and this is exactly what we want. Now, basically, our robot is kind of jittering there. And what we're going to do with our robot selected, if it is the player, we are going to simply take it out of the geometry layer. So we are only having the gun in space that it's moving. And when our bot will die, we will then restore that and play the death animation. And as you might have seen in the demo, rotate around, simply change the elliptic constraint to rotate around the dead player. So for now, we're going to leave that to off. And as you can see, there's many details that we have left and we did not go back, visually speaking. So the next tutorial, since we are now able to move and walk around our world, we're going to be able to tweak the visual in a way that we found appealing. Since we now have the ability to move around, it is going to be a lot easier for us to run some visual tweaks. So the first thing that we noticed for quite some time is it is overly bright. The first thing that I'm going to do, I'm going to tune down the sun intensity. So under the outliner, I'm going to pull my sun object up, and I'm going to go under light source properties, and I'm going to first cool it down to 10. And next I am going to head over to my default layout to have a better view of my final output. And I'm going to go under properties and material, and I am going to open up my result material, which is the final post-processing phase of our render. I'm going to open up user variable, and I'm going to start by changing the gamma to 3.275. The exposure will be minus 0.015. I come up with these values by simply moving around and testing, trying different kind of combination. And I feel that what we're about to set give basically good results. So with that set, I am going to move on and change my Skybox material. So I am going to go under here and type Skybox, and I am going to increase the strength of that Skybox. If I look where my sun is located in this direction here. I'm going to push play to be able to move around freely and align myself in a good angle here. And for the strength of my Skybox, I feel that a value of 2.5 basically give good results. And if I pull the blur all the way up to 5, we are going to be able to then later change the bloom to have a nice effect around these edges here. This is exactly what I'm going to do. I am going to pull the bloom material here, and under user variable, I am going to change these value to be something a bit more drastic than what we're having. For the max threshold, I'm going to set it all the way up to 10. And as you can see already, I start to have those halo here that are created. And for the min threshold, I am going to set something around here, which is going to give me, as you can see, we can have now see the circle of the sky as I change this. And I am going to go for a value of about 4.275. And next, what I'm going to do, I am going to increase the bloom inside my composite material. So I'm going to jump here and comp for composite. And I am going to crank that all the way to 1 to have something that really stands out. I also noticed that my gun here is pretty blurry because of the depth of field. So I am going to open up the depth of field, DOF. These materials are all part of the render layers here, used in the render layers here that are basically part of the render that is implemented inside. All we are doing now is just simply running some tweaks to fit more the current scene that we're having. So with that said, we are going to go under depth of field, and to test the depth of field, I'm going to put myself near a corner. And basically what I'm looking for is close to my gun here and far over there. So if I put a value of 0.002 on both the blur clamp and the blur bias, I should have something that give me a slight, as I change here, we can see that in this area, if I put it back to 0, we have a slight blur. I don't want to have it too blurry, just a simple blur. And also for my gun, I simply want to have this area here. If I increase or decrease the bias, as you can see, my gun become more and more blurry, as well as this area here. All I want is to have a slight blur here and a slight blur in this area. Of course, you can always tweak that to your liking. Me, that's the way I feel was giving me the best visual results. So now that we have that done, we are going to move to the screen space ambient occlusion. For that, I am going to go somewhere in here. I am going to enter one of the tunnel, and this is basically what I'm looking for here. This is the ambient occlusion at its best over here also. So we are going to tweak that slightly, and by changing the actual power of the ambient occlusion. The current power is set at 0.725. If we crank that to 1, we are having basically a perfect combination between light and dark. And we are inside, but also outside. If we look near the edges here, it's not too dark and it's not too bright. We have a relatively nice transition going on here. So next, I am going to change the probe for my shadow map. And for that, I'm going to align myself near the wall here so I can really see like a transition going on from here to there and also in the back. So I am going to go in the outliner, select my first probe. And actually, I am going to go under the coding because I basically need to work with two property window at the same time. So I am going to select my first probe, properties and probe. Here I am going to set for my first probe that the zoom is at 45. And I go around and simply tweak and try to find the best combination. And here I am going to pull the constraint. So I got the probe properties and the constraint of that probe. And yeah, as I was mentioning, I just walk around and simply try what is the best distance, what is the best zoom for probe 0, 1, and 2, and what is the best clip start and clip end. You can also adjust them to your liking as well. I feel that the values that I set here give somewhat a very good result. So we got zoom at 45, clip start minus 30 and 30. And because all these settings were actually settings that come with the Energy Sandbox. So the distance is at 20 for probe 0. Yes, let's move on to probe number 1. For probe number 1, the values that I come up with was a zoom of 75. And we can already see that it's sticking effect over there. And minus 40, and 40. And for the distance, it's going to be 47.5. And for probe number 2, the values that I come up with are basically 120 for the zoom, which is basically half of what it was, and minus 60, and 60, and the distance will be 95. And like that, we are basically having the best possible shadow at all time inside our scene. We have also another problem to fix that we are going to fix in a moment. I just noticed when I was inside that our gun is basically entering the wall, as you can see here. We need to fix that immediately before moving on. So this wrap up the visual tweaks, and we are going to move on and fix this little problem here. And also probably going to start coding now how to collect items. Before moving on with the collectibles logic, we are going to fix our gun entering the wall problem. First thing we're going to do, we are going to change the depth range of our camera. I'm going to close the properties here and select my geometry. And under camera properties, instead of having the clip start that is a bit far, I'm going to bring it in a lot closer. I'm going to put the value like 0.03. And as you can see now, even the range of our ambient occlusion is changing, and we have way better distinction between the ambient occlusion around the crease of the gun. Now, what I want to do is there's multiple ways we can fix this. One way is simply to change the depth range of the gun before and after it is drawn. So we are going to create a new script under MicroBots and then script, asset and new script. And I'm going to call it depth range. And I'm going to create a to event on draw before the gun is drawn and on display after the gun is drawn. I'm going to create that. With my gun selected this time, I'm going to select my blaster here, object properties, and I'm going to create a new thread. And I am simply going to drag and drop my depth range here. And I'm going to go back to my code editor, select depth range. And all I want to do is to change the range here to be in the range of 0 to 9 before the actual blaster is drawn. And when we are done, we are going to restore that back to 1. If I build, as I go closer to my wall, now my blaster does not enter the wall. There's a couple of things also since I'm here. I found out before recording this session that the shadow here of my player is pretty jittery. This is because we are actually running the depth pass before updating. So updating our bot. So what I'm going to do is I'm simply going to drag my geometry render layer on top of the right depth. And like that, I'm not going to have any frame of delay calculating and updating the position. And right after that, I will grab the shadow of my player running. Just a little tweak to make things a bit more pleasant. Now, the gun is also not really intimidating right now. I found it pretty small looking at it. So since I have my blaster selected here, I'm going to go under object properties. And I am going to select that the orientation is in local space. And I'm going to give it a little boost, let's say on the X 1.5 to make it look a bit more intimidating. And I can find a good value here by drag and drop it to make it look more proportional. And I'm going to pull it also a bit more in the front like this. And like that, I think our gun look a lot better than it was. Another thing that I want to implement is right now, as I move forward or backward, left and right, I feel my gun is extremely static. What I want to do, I want to implement a motion that is going to go up and down as I move. So I'm going to go back in my bot controller and I am going to declare a new variable that I'm going to call walk motion. And this is going to be an accumulator. I'm going to use a sin curve and I'm going to analyze the motion, how fast I am moving. And based on the sin curve, I'm going to move my gun up and down, which would make it look a lot more realistic, relatively realistic. So I'm going to go back on my update, and at the bottom here, after I rotate my robot and have my axis all set, I am now going to calculate the actual motion here. So the motion, I'm going to max it to make sure that I have at least a little value to play with. So when I'm on idle mode, the gun would go slightly up and down. As I move forward faster, the gun will start moving up and down faster as well. So I am going to get the length of my axis here. It is already normalized. I could have skipped that. Oh, if it is 0, actually, it would cause issues. So by calling normalize safe, it is handling the 0 axis length case here. So our motion is going to be our motion multiplied by the speed, our movement speed. And next, I'm going to add the following code to calculate our walk motion. So our walk motion accumulator plus the application delta time multiplied by our motion that we have calculated here. Now, we're using a sin curve here. So we're going to normalize the angle just to make sure that we got a accurate smooth motion. So we are normalizing our walk motion, and similar as we did for our camera, we're going to feed in the constraint data here. So we are going to create a new constraint for our gun. I'm going to go under constraint, add constraint, and this time is going to be an offset location. I am going to simply move my Y in local space to my Y in world space to move my gun up and down like this. So with that said, I am now gathering here on this line my constraint, and I'm going to multiply my model, my world matrix of my robot, and I am going to apply my sin curve and then transfer that value to the offset Y. Later on, when our gun is going to be shooting, we're going to reuse the same type of thing to make the gun go back and forth when the player is actually holding the shoot button. So for now, if we test this code here, I'm going to build and save. And as I move around, we can see that now my gun is following like this, which make it look a lot more realistic. And as I stop, we are going to have a slight movement here that is controlled by the 0.1. It is slightly moving when we are idling and get faster as we are walking around, running around our level.